All right, today we are going to look at solving nonlinear systems of equations graphically. We did linear systems of equations back in chapter 2 or unit 2, and now we're going to look at ones that aren't both lines. So, start with a definition. So our definition of a nonlinear system of equation is a system of equations. So again, system has two or more equations where one or more equations are not linear. Again, linear means a line. So we're going to be looking at parabolas for the most part today. If you remember when we did systems before, the solution to a system of equations, when we graph it, is where the equations intersect. And you can have one solution, multiple solutions, or no solutions, and we can see these examples. So one solution would be if we had a line in a parabola where the line just barely touches the parabola at one spot. We could also have one solution if two parabolas just touched at their vertices. For two solutions, we could have a line going through the parabola and it's crossing at two spots. Or if we had two parabolas, those parabolas would intersect at two spots. We could also have no solutions, which is where the line never crosses a parabola or the two parabolas never intersect. So we're going to look at example 1 here. In this case, we are going to have a line and we're also going to have a parabola. So the first with the line, I'll do the line in green. I want to get the y by itself. So I would subtract 4x and then divide by -1. So I have positive y. So that would give me y equals positive 4x minus 1. So that would be starting at 0, -1, and we would go up 4 over 1, up 4 over 1, also down 4, left 1, down 4, left 1. And then you want to do your best to make a straight line. If you need a ruler or use your ID, make a straight line right there. All right, now we have to recall some information about graphing parabolas. So this parabola, which I'll do in blue, is in standard form. The vertex, remember, is the hk. The h is the opposite of what you see because the general form is x minus h. So our vertex would be 2, 5. So I would go over 2 and up 5. 1, 2, 3, 4, 5. And then we also want to remember our table, parent graph table for a parabola. So our parent graph table, remember, goes from -2 to 2 in the x's. And then we can plug each of those x's in and square them. So -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. All right, now, because we have an a value, this a is -2. Remember, this would mean it is flipped or opens down. And it is also going to be vertically stretched. So to do that, remember we take our y values and multiply them by the a. Our a is, again, in this case, -2. So my new y values would be -8, -2, 0, -2, and -8. So I would go to my new vertex, and I would now go left 1 and now down 2, because that is our new point. And if you notice, that is a point that we had from our line as well. So we know that they would intersect at 1, 3 because they both shared a point. I would want that mirror image point, right 1 and down 2. And then we're going to go left 2 and down 8. So we go left 2, down 8, 1, 2, 3, 4, 5, 6, 7, 8. And then the mirror image, right 2, 1, 2, 3, 4, 5, 6, 7, 8. And so these would only intersect at that one spot. They would come close to intersecting at a lot of other spots, but they would only intersect at that one point of 1, 3. So that's one example of a parabola line that would only intersect at one spot. If we go to the next page, looking at number 4, I'll do the first one in blue. I'll actually do that bottom one. The bottom one's going to be a little bit easier. So the bottom one, our vertex would be -1, because again, it's the opposite of what we see, -10. And so I'll go left 1 and down to 10. And then again, I'm doing my normal parabola table. So -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. So I'll go left 1, up 1, right 1, up 1, left 2 from the vertex, and up 4, right 2 from the vertex, and up 4. Now notice how we have all this room or space above our last points that we plotted. So I'm going to do one more point. I'm going to do -3 and +3. And we know 3 squared is 9. -3 squared is also 9. So I'm going to go left 3 from here and up 9. And then right 3 from my vertex and up 9. And that just gives me a little bit more precision as I go and try to graph this. All right, my green, my vertex, the top one, is going to be -2, -9. And so when I go down here, left 2, down 9, oh, notice I'm already intersecting at a point that I had. So I know right away -2, -9 is going to be one of our solutions. We may have more, we'll see. And since our a value is 2, I would have to multiply all of these y values by 2. And again, I'm not going to worry about the 9s for now. If we need to go with those, we can. 4 times 2 is 8. 1 times 2 is 2. 0 times 2 is 0. 1 times 2 is 2. 4 times 2 is 8. So from my vertex, I would go left 1 and up 2. And then mirror image right 1 and up 2. From my vertex, left 2 and up 8. That would share that point right there. So there's our other intersection point in this case, which is going to be -4, -1. My other mirror image point, right 2, up not up 8, will be right there. And they would not intersect any other places. All right, I want you to pause the video for a moment and try doing number 5 on your own. Okay, for number 5, the first one would have a vertex of -3, 7. And it's opening down because of the negative. So I would just go left 1, down 1, right 1, down 1. I would go left 2, down 4. And then right 2 for my vertex and down 4. My bottom one, I'll do that in green. That would have a vertex of 2, 4. So I go right 2, up 4. Follow my normal pattern. -1 squared is 1, +1 squared is 1. And then I would do left 2, up 8, 1, 2, 3. Sorry, left 2 and up 4. 2 squared is 4. And then right 2 and up 4. And we will see that these are never going to intersect, so therefore this one would be no solution. And that is graphing systems of nonlinear systems. If you enjoy this video, please like and subscribe. Thank you.